Hello and welcome to a new video on IGCSE Mathematics. In this video, we shall be discussing graphing. The diagram shows the graph of a function. Put a ring around the word which correctly identifies the type of function. So we should know that this is what we call a cubic function. How do we know that? Simply because it intersects the x-axis here 3 times. So we can tell that we have 3 factors, x minus a, x minus b, x minus c. So this is definitely a function that has x power 3, and therefore this is a cubic function. Not all cubic functions intersect 3 times, but any function that intersects the x-axis 3 times must be a cubic function. The graph of y equals x minus 3, x plus b, x plus 2 intersects the y-axis at negative 30. Find the value of b. So if it intersects the y-axis, this means that x equals 0 at this point and y equals negative 30. So if we put x as 0 and y as negative 30, we get the following equation. Negative 30 equals 0 minus 3, which is negative 3, 0 plus b, which is b, and 0 plus 2, which is 2. So negative 30 equals negative 6b. If we divide by negative 6, we get b equals 5. When x is greater than 0, the graph crosses the x-axis once. Write down the coordinates of this point. So again, x-axis here means y equals 0. So we want to know when y is 0. So since we have 3 brackets multiplied by each other, any value that makes one of these brackets 0 makes the y 0 as well. So we actually have here 3, 0, negative b 0, and negative 2, 0. Of course, we already got b, so this can be written as negative 5, 0. They want the point where x is greater than 0. So this is simply going to be 3, 0. So 5 is correct, and 3, 0 is correct as well. The diagram shows a sketch. This now is a quadratic function, not a cubic function. And it's a sketch of y equals 18 plus 5x minus 2x squared. Find the coordinates of a, b, and c. So to begin with, b is quite simple to find because at b, the x is 0. So we put x as 0, and we want to get y, so we just plug 0 here. So we get 18 plus 0 minus 0. So b is simply 0, 18. This is the easiest one to get. Now for a and c, they are on the x-axis. So this means that y is equal to 0, either at c or at a. In both cases, y is equal to 0. So if we solve this equation equal to 0, we can get the values of x. We can actually put 0, 0 here. And we want to find the values of x that satisfy. So 0 equals 18. Let me write this down. Excuse me. So 0 equals 18 plus 5x minus 2x squared. We can change the signs. So we get 2x squared minus 5x minus 18 equals 0. I just multiplied by negative 1. So this is positive, this is negative, this is negative. Now we have an equation here. We're not required to show work, so we can just use the calculator, mod 53, to get the values. We're not here required to show details of our work, so we can just put 2 for A on the calculator, negative 5 for B, and negative 18 for C. So the values are negative 2 and 4.5. So either x equals negative 2 or x equals 4.5. Of course, logically, A will be negative and C will be positive. So I will put negative 2 here and 4.5 right there. So negative 2, 0 is correct, 0, 18 is correct, and 4.50 is correct as well. Next, we move on to graph sketching. sketch the graph of y equals x minus 1 squared. So this is a quadratic. You should know from your knowledge of quadratics that the vertex of this parabola here is going to be at 1, 0. This is where the vertex is. And the x-intercept is incidentally also 1, 0. And since x is positive, so this is a smiling parabola. So a simple sketch would be something like this. Let me redraw it for accuracy. Slightly better, not great, but slightly better. So this point here is 1, 0. Now we want to sketch the graph of the other function, y equals half x plus 1. So it is also a good idea here to try to get the y-intercept before we move on. Let's put x as 0. And let's get y. So y will be 0 minus 1, which is negative 1, power 2, positive 1. So this here is point 0, 1. Now for the second equation, this is a line. So again, we need to get points on the line. So we have x and y. Maybe put x as 0 to get the y-intercept. So y here is 1. And if you put y as 0, you can solve for x. So 0 equals half x plus 1. Take the 1 to the other side, becomes negative 1. So x equals to negative 2. So we have negative 2, 0. So for the second graph, we start at negative 2, 0. And we graph the function. So these are the points of intersection between the curve and the line. They were not asked for here in this point in this problem, but you might be asked to get the points of intersection. So these are the proper sketches here. And they should intersect on the y-axis like we did. Here we want to sketch this graph. Again, this is quite easy. We create a table of x and y. For a line that just has x power 1 and y power 1, you just need 2 points. More, you don't need anything more than that. So I'll put x as 0 and I'll put y as 0. I'm going to try to find the other letter. So when x is 0, I have negative 4y equals 12. So y equals negative 3. So here we have negative 3. And then when y is 0, 3x equals 12. So x equals 4. We just put 4 right there. So you have 0, negative 3. 0, negative 3 is on the negative y-axis like this. And you have 4 and 0 right there. And if you just join these 2 points, you get a straight line. Of course, I'm drawing as accurately as possible given that I'm drawing on the screen, but you get the idea, of course. You need to use the ruler and pencil in order to graph this line. So y is at negative 3 and x at 4. These are the correct values. Here we need to graph this parabola, y equals x squared minus 3x minus 4. So the best and easiest way to graph a parabola is first to factorize to get the roots. You don't have to factorize, you can just use mode 5-3. You need the roots of the equation. So equation solver, and you put in a equals 1, and b equals negative 3, and c equals 4. So 1, then negative 3, and then negative 4. And the calculator gives you the two roots, which are negative 1 and 4. So x equals negative 1 and x equals 4. This tells us that y is 0 when the values of x are like this. And we also put x equals 0 to get the value of y, and y will be negative 4. So we have 3 points that we need to graph to begin with. We have negative 1, 0. We have 4, 0. And we have 0, negative 4. Let's just plot these points. So -1, 0, and 4, 0. And 0, -4 is somewhere here. It's also very important to get the turning point. So the turning point is halfway between the roots. So halfway between these two numbers, we have the turning point of the parabola. So if we get the average of -1 and 4, this gives us 1.5. So at 1.5, we have a turning point. Of course, you can put 1.5 into this equation to get the y coordinate. So 1.5, and you plug it into the equation. 1.5 squared is 2.25 minus 3x, so minus 3 times 1.5, which is 4.5, and then minus 4. So you get -6.25. So you understand that roughly the turning point is somewhere here. And you can now graph the parabola accurately. So it looks something like this. And you should put here -4 as well. It's not supposed to be a V, it's rather supposed to be like a U shape, a curved U shape, but these are the correct points. So like we did, they have here -1 and -4 and +4 on the x-axis. This is important. The minimum does not need to be graphed accurately, but it does need to be in the fourth quadrant, like we did. It has to be here. And we can only figure this out if we actually calculate the minimum, which would be 1.5 and -6.25. So these are roughly correct shapes. Here we want to graph y equals 6 power x. So this is an exponential function. Exponential functions have a certain behavior that you need to be aware of. No matter what the value of x is, this function will never be 0. So this is something you need to understand and to be aware of. If you let's try to put random values of x. So let's put maybe -3, -2, -1, then 0, and then 1, 2, 3. And let's see what happens to the values. So for 0, 6 power 0 is 1. And then this is 6, and then this is 36. And then 6 power 3 is 216. So you can see that the y values are quickly rising up. Now for the negative powers, 6 power -1 would be like 1/6. This would be 1/36. And this would be 1/216, which is a very small decimal. If you try to divide 1 by 216, this is 0.005. So what does this tell us about the curve? It tells us that at -3, it's not quite 0, but it's almost 0. So at -3, the graph is somewhere here. At -2, we have 1 divided by 36, which is 0.02, so not great. Again, slightly up, still very close to the x-axis. Actually, these aren't even accurate. Let me do them again. So something like this, and something slightly, ever so slightly above it. For -1, you have 1 divided by 6. This is now 0.1, so this is slightly higher than the other two. So it looks something like this. And then 0.1 is here. So this is an easy point to draw. And then 1.6. So now we are increasing very quickly. And 2 and 36. This is way beyond our scope. So we don't actually need to draw these. We just understand that it rises up very quickly. So the curve is going to look something like this. And it plateaus above the x-axis. So we say that the x-axis is a horizontal asymptote to this graph. So the curve keeps decreasing, but never actually touching the x-axis. As I told you, 1 divided by 26 is 0.0, excuse me, 1 divided by 36 is 0.027. So you can see that we are approaching 0, but not quite reaching 0. 0.027, 0.005. We keep decreasing, but never actually crossing the x-axis. This is the graph of an exponential function. And they are interested in your y-intercept. So you have to make sure that you have the correct y-intercept here. On the diagram, sketch the graph of y equals 1 over 2x. So first, let's create a table for 1 over 2x. Again, when it's a strange function that you don't know, just put -3, -2, -1, 0, 1, 2, 3, and start getting points. So for -3, we have -1 over 6. For -2, we have -1 over 4. Then we have -½ For 0, it's 1 over 0, which is infinity. So this doesn't work. It's not that it doesn't work. It's something we're going to talk about called a vertical asymptote. And then for +1, we have half. For +2, we have quarter. And for +3, we have 1 over 6. Let's get the decimal value so that we understand what's going on. So 1 divided by 6 is 0.1666. So just 0.167. And here the negative will be the same value, of course. Quarter is 0.25. We know that. This is -0.25. Here we have -½ and half. So now we have the first couple of values. Let's try to plot these and see what happens. So for -3, we have -1 over 6 or -0.1. So at -3, we have a point here. At -2, we have excuse me, I made a mistake. This is -0.167. So let me just repeat this. So let's assume that this is -3 here. It's going to be in the negative. And then for -2, we have -0.25. This is slightly larger in the negative sense, of course. And then for -1, we have 0.5, which is something like this. So you see that we have 3 points that look like this. And then for the other side, we have a reflection of these 3 points as well. So let's do 1, 2, and 3. So we have 1½ 2 and 0.25, 3 and 0.167. We're still not quite sure what's going on. So we want more information about what happens between -1 and 0, for example, or 0 and 1. You can see it's the same thing. So let's try 0.5 here. What happens if we have 0.5? If we have 0.5, y is 1. So at 0.5, it's even higher. You can start getting an idea of what is going to happen. For the negative, of course, it's going to be the same, but negative, so -1. Now it makes a bit more sense. As we approach the 0, the values tend to get very high. So the curve is going to look something like this. And again, it plateaus as it approaches the x-axis. So we have an asymptote here. We have actually 2 types of asymptotes here. We have a horizontal asymptote, which is the horizontal line that the curve never touches. But we also have a vertical line, which is the y-axis, which the curve never touches as well. So the asymptotes here are the x and y axes. Now we need to solve this equation. This is quite simple. You take the 2x to the other side. So 1 equals 4x power 2. You divide by 4. So 1 over 4 equals x power 2. You can take the square root of both sides, but remember this is positive negative. So x will equal positive -½ And this is the final answer. So this is the correct sketch, and positive -½ is correct as well. In this question, we're told sketch the graph of y equals x plus 1 times 3 minus x times 3 plus x, indicating the coordinates of the points where the graph crosses the x-axis and the y-axis. So I would recommend you to start with the axes. So for the x-axis, we know that y equals 0. So we have x plus 1 equals 0. So x equals -1. 3 minus x equals 0. So x equals 3. And 3 plus x equals 0. So x equals -3. So we have 3 points, -1, 0, 3, 0, and negative 3, 0. These must be plotted on the graph. Let's do that now. So we have negative 1, 0, and negative 3, 0, and 3, 0. Next, we move on to the y-axis. Y-axis means x equals 0. So y equals 0 plus 1 times 3 minus 0 times 3 plus 0. This is equal to 1 times 3 times 3. And this is equal to 9. So we have another point here at 0, 9. We can plot it here. Now we got 4 points. We can get some other points. So you can create a table of values, x and y. We already got a couple of nice points, but we can add some more. Of course, this 9 here means we have a point 0, 9. Now let's add some more points. So we have negative 1 and 0, 0 and 9. Excuse me, let's start with negative 3 to give ourselves some space. So we have negative 3, 0, and then negative 1, 0, 0, 9, and 3, 0. Let's just add some random points in between. So let's add, for example, negative 2. Negative 2, if we put it into the equation, y equals negative 2 plus 1, 3 minus negative 2, and 3 plus negative 2. So this is equal to negative 1 times 5 times negative 1 again, times positive 1. So if we multiply all of these together, we get negative 5. So we have a point here, negative 2 and negative 5. Let's also try putting in here 1 or 2, doesn't matter. So y equals 1 plus 1 times 3 minus 1 times 3 plus 1. So we have 2 times 2 times 4, and this is equal to 16. So we have 16 here. Now, we want to plot these 2 points. So we have negative 2 and negative 5. So we have a point somewhere here. And then we also have 1 and 16. So 1 and 16, which is somewhere at the top here. Now that we have these 2 extra points, it will be very easy to draw the curve. We just connect all the points together, so it will look something like this. And you can just extend it to look something like this. So our graph looks pretty much like the one in the marking scheme. In this problem, we're told sketch the curve y equals x power 3 minus 1.5 x power 2 plus 1. So another nice way to graph is to find the turning points. So if we have y equals x power 3 minus 1.5 x power 2 plus 1, you can get the turning points by getting y dash, which is 3x power 2 minus 3x. Then we set that to 0. And we find the values of x that satisfy. So we can take 3x as a common factor. We are left with x minus 1. So at x equals 0 and at x equals 1, we have turning points. Now we plug those into the original formula to get the y values. So when x equals 0, we get 0 minus 0 plus 1. So we get y equals 1. For x equals 1, we plug it again into the original formula here. 1 minus 1.5 plus 1, this is equal to half. So we have 2 points that are turning points. We want to figure out whether they're maxima or minima. So let's get y double dash. So y double dash will be 6x minus 3. For x equals 0, we have y double dash equals negative 3. So this is a frowning curve. This is a maximum point. For x equals 1, we have y double dash equals 3. And this is a smiling curve. So we have a minimum point because y double dash is positive, so it's a smiling curve. So we have a minimum point. How does this help us? So now we know that at 0 and 1, here we have a maximum point like this. And at 1.5, 1 on the x and half on the y, we have a minimum point that looks like this. So we already have the turning points of the curve. Now we can graph the rest of it quite easily. We can just extend it like this and like this, and we have our graph. So this is what the graph should look like. It's quite similar to our graph. So another nice way to graph is to use turning points. On the diagram, sketch the graph of y equals x minus 4, x plus 1, x minus 2, indicating the values where the graph crosses the axes. So here we're given the factored form, and we can get the x-axis points and the y-axis points. In the previous problem, we were not given the brackets, the factors, so we could not get these points. So here we're going to say x-axis implies y equals 0. And this implies that each bracket on its own is equal to 0. X minus 4 equals 0, x plus 1 equals 0, and x minus 2 equals 0. So here x equals 4, here x equals negative 1, and here x equals positive 2. So we have 4, 0, negative 1, 0, and 2, 0. Next, we move on to the y-axis. Y-axis implies x equals 0. So if we plug 0 into the original equation, we get 0 minus 4 times 0 plus 1 times 0 minus 2. If we multiply these out together, we get negative 4 times 1 times negative 2, and this is equal to positive 8. So we have the point 0, 8. Now we draw our table, x versus y. And we have the x values that we got are negative 1 and 0 and 2 and 4. And we have here 0 and 8 and 0 and 0. We can get some intermediary points. For example, we can get here when x equals 1, what happens? So when x equals 1, if we just plug it into the original equation, we get 1 minus 4 times 1 plus 1 times 1 minus 2. This is negative 3 times 2 times negative 1. And this is positive 6. So we have 1 and 6 here. You can get half as well. Negative half, I mean. So to get an intermediary point here. So again, this would be negative half minus 4. Negative half, excuse me. Negative half plus 1. And negative half minus 2. So negative 4.5, positive 0.5, and negative 2.5. You can use your calculator to evaluate these numbers. I'm going to do that right now. So negative 4.5 multiplied by 0.5 multiplied by negative 2.5. This gives us 5.625. So it's a long decimal. We generally don't like that while sketching, but it should give us a rough idea of where the point is. So this is 5.625 here. Finally, we can plug 3 in between 2 and 4. So we have 3 minus 4, 3 plus 1, and 3 minus 2. So negative 1, positive 4, and positive 1. This is equal to negative 4. So we have the point 3 and negative 4 as well. These are sufficient in order to plot our graph. So we have -1 and 0. This is the point here. And then we have -0.5 and 5. So this would be somewhere here. And then 0 and 8. So this is further up. And then we have 1 and 6. So 1 and 6 would be somewhere here. And then 2 and 0. This is 2 and this is 1. And this is -1. And this is -0.5. So 2 and 0. And then 3 and -4. Right there. And finally 4 and 0. So the curve looks pretty much evident here. It will look something like this. And this is the correct curve here. For our final problem, we are asked to sketch x power 3 minus 4x. This can be factored quite easily. If you take x outside, you have x squared minus 4. And this is equal to x times x plus 2 times x minus 2. So we can get the x-intercept and the y-intercept. So for the x-axis, we said y equals 0. So either x equals 0 or x plus 2 equals 0 or x minus 2 equals 0. So either here we have like 0, 0 and -2, 0 and 2, 0. These are the first 3 points that we will use. For the y-axis, we just put x as 0 and we get again 0, 0, which is a point we already got. Now we can draw our table, x versus y. We have x values of -2 and 0 and 2. I'm going to leave some spaces here so as to get other points. Let's put -1 and +1. Let's try -1 into the original equation. So if we have here x equals -1, we get -1 times +1 times -3 by plugging into the brackets, and this gives us 3. If we try x equals 1, we get 1 times 3 times -1. So this is equal to -3. So we have here 3 and -3. We have enough points now to start drawing. So -2. Let me just give myself some space here. -2, -1, 0, 1, and 2. For the -2 and the 0 and the 2, these are on the x-axis. For the -1, we have +3, which is somewhere in the positive here. And for 1, we have -3, which will be somewhere here. Now that we have our points, we can just sketch the graph. Okay, so I made a mistake. So the maximum is not necessarily the highest point that we have. So maximum can be somewhere beyond it. You are not required to get the maximum and minimum for every problem. I just used that when we were getting the equation for which we had no intercepts. So instead of the intercepts, to get an idea about the curve, I got the maximum and minimum to help me graph. But in general, you don't need to do that unless specifically told to. This is the final image of our curve, and it looks fairly similar to the one in the marking scheme. And this brings us to the end of our video. I hope this has been beneficial. Thank you for watching.